All right, good morning, good evening, good afternoon, and here we are with another round of Tuesday tutoring questions. So we got 3 that we're going to look at from our assignment number 5 on linear regressions. Also, there's a few questions that we're going to then look at from the past assessment on the stats as well as the previous formative assessment for Precal. So let's go and dip right into the problems from the homework set. So I got my handy dandy graphing calculator here off to the side, and I have my problems over to the left. So let's go ahead and we'll start with number 16. Yeah, number 16. So let me just widen this out so I can see more of the output. I still got my screen here. All right, so we're asked was to come up with the line of best fit for these points. So let's go ahead and go into our stat. I'm going to edit. So you see I have stuff in my L1, so I'm going to clear that out. So clear, enter. So I got a clean L1 and L2. So I'm going to start with my X values. So I see -2. So -2, -1, 0, 1, 2. Okay, so there's my X values. And now I want to put the corresponding Y values. So I see 6, 4, 2, 6, 4, 2, 1, 1. All right, so now again, as I mentioned in class, this is the most important part, is us putting in the data and making sure that we did it correctly. So I'm looking here to verify -2, 6, -1, 4, 0, 2, 1, 1, 2, 1. Thumbs up, firm handshakes are all around. So let's go ahead and push forward. So I want the line of best fit. So go to stat again, this time calc, and I want to select that option number 4, linear regression. Okay, so L1, L2, L1 is the X values, L2 is the Y values, correct. I'm not going to graph this one, so I'm not going to worry about storing the regression equation line, and I'm just going to calculate. So I see that my line of best fit is going to be Y equals -1.3x plus 2.8. Now, here's a thing that I would recommend you do, and actually, sorry, not a recommendation, it is a requirement that you need to do, and that is you're going to put this little hat over the Y. So this is going to let us know that this line is not going to give me the actual Y value that I see on these points. It's going to give me an approximation for Y. So that's why I put this little hat, and that's what we call it, Y hat. So I would plug in an actual X value, and then what I get out of the equation is an approximate Y value. Okay, so I think the question had then also followed up by asking, is this line a good fit for the data? So that requires us looking at the R value. So I don't have an R value here, so notice. So that means, oh yeah, I have a new calculator. So I got to make sure that the stat diagnostics is on. So remember how we do that, and again, it's just a one-time thing we only have to do. So if you already did it with me in class today, then you're good. You'll never have to do this again. But for those of you that may have not have been in class or sleeping, you can hit the mode button, and you'll notice here my stat diagnostics is off. So I'm going to go down here. So stat diagnostics, notice it's off. We need to turn it on, and once you do it once, you're set for life. Or until you got to refresh the batteries. All right, so now we're going to quit, go back to stat, and redo it again. Okay, so now I get, oh, there's my R value. So I'm going to write that down. So R is, and let me write approximately -0.948. So definitely bigger than 0.5. So this is a very strong correlation. So I'm going to write that here. So strong correlation. So that means this line is a very good fit to the data. And if we look, the data already looks very much like a linear. We could see it's a negative relationship. So as one variable is increasing, the x, the y variable, is decreasing. Okay, so strong relationship. All right, so now let's go ahead and, whoops. All right, sorry about that. Let me go back to, well, okay. Just got to see behind the curtains here for a second. All right, so now we move on to, this is now question number 20. All right, so now 20, let's zoom in here because I want to read this question. So it says the mean salary in thousands of dollars of public school teachers in the United States from 2002 to 2008 are shown in the table. So we have it here. So mean salary in thousands of dollars, and then we have our years over here. Use a graphing utility to create a scatter plot of the data with t equals 2 corresponding to 2002. So for part A, what I want to do is I'm going to rewrite the table just so I have the way I'm going to enter my coordinates. So 2002, I'm entering it as 2, which means 2003 would be 3, 4, 5, 6, 7, and 8. So those are going to be my quote-unquote x values. My y values, we're just already going to keep them as is. So 44.7, 45.7, 46.6, 49.9, oops, 49.0, 50.8, and then finally 52.3. So I'm going to write this over here in red. So this is my x and that is my y. Okay, so we're going to using graphing utility to create the scatter plot. Do we have to draw the scatter plot? No, we're just going to put it in our calculator. All right, so go into my stat here, edit. So L1 and L2, I'm going to clear those out. Clear. And now we're going to go ahead and enter my L1s. So we got 2, 3, 4, 5, 6, 7, 8. The most tedious part of the problem, but also the most important. We want to make sure and we're not going to mess up in putting in our data point. Because again, the calculator is not going to say, oh, error. It's going to give us a line of best fit regardless of what we punch in. So we want to make sure we're punching in the right stuff. And after I've typed it in, I want to just again verify that there are no typos with any of the numbers. Okay, so this looks all good. All right, so first, scatter plot. So remember, we're going to do second stat plot. So we're going to turn on that stat plot, the first one, and make sure that we've selected the first graph, that scatter plot. L1 and L2 are the X's and Y's, so we're good with that. And then remember, we do zoom and zoom stat. There's my scatter plot. All right, so there we go. There's part A. Now part B says use the regression feature to find a linear model for the data. So we can already anticipate I should be getting a positive correlation, so a positive slope line. And since if you look, man, this looks super linear. So I'm probably going to get an R value very close to 1, a positive 1. So you see how I'm already like kind of anticipating what my answer should be. So if I get something weird like, oh, I got a R value of 0.2, something went wrong. Like, let me go back and let me again double check, triple check that I entered my data right. So now let's go ahead and we'll go stat. We're going to go calc and go to our linear regression, L1, L2. I'm not going to graph the linear equation, and I'm going to get the information. Look at that R value, 0.992. Woo, that is very close to 1. So that is a super strong relationship as anticipated. Okay, so for my part B, I'm going to write my regression line. So line of best fit. So again, remember, I'm going to write y hat, because we're approximating the y value with this line, is equal to, and now I'm just going to copy over my numbers, a 1.264 x plus 41.793. So I'm around to 3 decimal places. Okay, now I wrote it like this, but the variables that were given to me were t and s. So now I'm going to go back here and replace that. So the y is not going to say y hat, it's going to say s hat. And this is not going to say x, it'll say t. So we're going to fix the variables. Don't leave it as x and y, because we don't have x's and y's, we have t's and s's. Okay, so that's part B. Now part C says, use the graphing utility to plot the data and graph the model in the same viewing window. Is the model a good fit? Well, remember, that's the whole reason we got this R value. So now we're going to be able to objectively say if it's a good fit. So R is approximately 0.992. So this is a strong positive correlation. So this is a good fit. Okay, so that's my part C right there. You can plot it. We'd still plot this line on top of the scatter plot, but that's what the R value helps us to determine in a more objective way, as opposed to just us kind of like staring at the picture going, I don't know, maybe, maybe not. So that's what we use the R value to help us determine. Now part D says, use the model to predict the mean salaries in 2016 and in 2018. So 2016. So if we're using, so the year is 2016. What would that correspond to as our T value? So look at how we did. So 2002 was 2. So 2016 would be, drumroll please. Hopefully you pause and you kind of think about it. 16. If you said 16, give yourself a high five because you got it correct. All right, so now we're going to approximate the salary. So this is why we write S hat. Okay, so now we're going to plug in 16 into our equation. So 1.264 times 16 plus 41.793. So when we do that, and we'll roll this over. So here's how you can use your calculator. So instead of writing all this out or using this approximate number to get another approximation, which is going to be slightly off, under your vars button, all these numbers are stored in a calculator. So under your vars button, push here. You're going to see right here under regular vars variables, you'll see this option 5 says statistics. Scroll down to that. Okay, and now you're going to see there's this third option up here which says EQ. So push the right arrow over, EQ. So it's saved your regression equation, and then here's all the coefficients. So we need is A and B. So I'm going to go ahead and say, all right, A. So remember, and I'm going to label it here. So remember, this is A, this is B. So A times 16 plus, and I'm going to go back into the variables. So again, under statistics, EQ, and it's option 3, there's the B. And there we go. So we get 62.021. So remember, this is measuring in thousands of dollars. So our approximation would be that in 2016, the mean salary for teachers would be about $62,000. So it's not like, oh, it's going to be $62. What a cheap teacher. Okay. I would not be, able to live in a house if they were paying me $62 a year. Okay. So no, it means $62,000. Okay, so now for year 2018, so year 2018, now what would T be? Pause here, think about it, and now you're back. Hopefully you said 18, and if you did, again, give yourself another high five. So now we're going to go ahead and plug that in. So 1.264 times 18 plus 41.793. And again, this is important, folks. Show the work. Most of this we're punching in the calculator. I totally get it. It seems tedious, but a lot of you probably noticed that on the last two assessments, you got some partial credit because you were showing these steps and you fumbled on that last part. So imagine if you didn't show that, you would have gotten nothing. But at least if you're showing those intermediate steps, you're showing the setup. Hell, maybe I mashed it the wrong way, or I grabbed the wrong value, or I put the decimal point in the wrong place, but gosh darn it, I am going to get that partial credit. And that's what you don't want to leave on the table. Okay? Again, accuracy. We will get there. You cannot be 100% accurate overnight. So if you're one of those people that has those issues, keep on writing the problems out. So again, I'm going to do the same thing. So here's a quick way. If you have the newer calculators, here's where you save some time. Just push the up arrow, highlight the old thing that you just typed, and you can just copy and paste it right down there. Really nice and easy and simple to do. Okay, and now instead of 16, I'm going to fix that. 18. And now I get 64.55. So in 2018, an average teacher's salary would be $64,000. So if you think about it nowadays, it really isn't that high. But if we were basing it on this particular set of data, this would seem reasonable because we had a nice positive correlation. Now, here's the downside to extrapolation, okay, that I want you guys to understand. There's a limit to extrapolation, even if we had the best data ever. If this R was a perfect one, that's based on past performance. So for example, and I'm just going to take a little tangent here to kind of connect this to real life. When you buy stocks for like the stock market, one of the things they'll always tell you is past performance is no indicator of future earnings. Meaning the stock was like going through the roof. So like, oh, I bought Amazon, when it was like nothing. And now, oh, look at Amazon now. Like, oh, so if you go and you buy Amazon stock now, does that mean that it's going to continue to skyrocket and skyrocket? No, there's no guarantee. Oh, but in the past, it kept going up. Yeah, but that's the past. Who's to say what can happen tomorrow? Tomorrow, maybe the economy collapses and Amazon goes through the tank. Or, the internet just, implodes on itself and there is no more internet. There's no more going online. What happens to Amazon then? They can go out of business overnight just because of that. So even though the model might predict something, that's as if it's based on the previous data points. The further away we go from that, the harder it is to kind of rely on that prediction. So notice here, our data points stop at 8. So if you're plugging in 16, you're talking about a decade later. How many things could be happening between then and now? Maybe there's a recession. Maybe there's a pandemic, like what's happening right now. So yeah, that model was predicting this as if time stood still and everything was exactly the same. If we're close to the data points, then it's a reasonable assumption. But the farther away we get, it becomes less reasonable. So that's a subjective look at it. Okay? So, this is where, again, math meets real life. Okay? If we were all automatons and the world stood still, yeah, it would follow a nice linear equation, but we know things can happen from day to day. So the further away we get, the harder that prediction becomes, or the less reliable it becomes. So that's answering part D. All right, so now let's look at our last question here. So we have that the table shows the numbers T of stores owned by Target from 2000 through 2008. Part A is again going to tell us the same thing as we had in the previous question. Use the graphing utility to make a scatter plot with T equals 0 corresponding to the year 2000. Identify two sets of points in the scatter plot that are approximately linear. Okay, so we're going to look at the scatter plot and then identify those pair of points. All right, so like I did for the last one, I'm going to go ahead and write out the variables all over again. So 2000 would be 0, 1, 2, 3, 4, 5, 6, 7, 8. And that 8 would stand for our 2008. Number of stores, so we're going to write this 1307, 1381. Whoops. 1308. And 1682. All right, so let's go into our stat, edit, and I'm going to quickly clear out these lists. So again, you go up to the name of the list, hit clear, and push enter, and it erases everything you did in the list. So we're going to start at 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, now time to enter some numbers. Whoops. All right, so again, I'm just gonna one more time before I make the scatter plot, verify that I entered the numbers incorrectly. So I'm just going line by line, making sure I did not goof anywhere. Thumbs up, looks all good. Let's go ahead and go to the scatter plot. So second, stat plot, want to make sure it's turned on. It is. Correct lists. So this is the shorter version. I don't always have to go and push enter and go in here. You don't have to. Okay. Once it's turned on, you can just look here really quick. So that's why there's this little picture here. Okay, it's on scatter plot. It's L1, L2. Great. So it looks like it's supposed to be set up the way it is. Now, this is the thing you do have to do every time. Every time you change the data, hit zoom and zoom stat. So I'm going to show you right now, what if I didn't do that? What if I just hit graph, Mr. Sardui? Who cares? That's why you don't hit graph. Because now it's like, oh, something happened. The calculator's broken. No, it's not broken, Bill. It's that we're zoomed in wrong. So this is why we do zoom first and zoom stat. Hey, there we go. And now look at this scatter plot. Very weird looking scatter plot. It looks like there's two lines here. So this is why it said, identify two sets of points that are approximately linear. So this set of points, the first 4, formed a straight line. But then these last 5 formed its own straight line. Okay, so now, so we've identified the two groups. So I would say, so I'm going to highlight it here. So this group here, the first 4 made its one line, and then these 5 made their own line. But when we come up with a line of best fit, it's going to make a line based on all the points. So it's not going to like draw a line here and a line here. It's going to make a line that kind of fits best amongst all the points. So now part B says, okay, let's use our regression feature to find a linear model. Okay, so I'm going to go ahead and go stat, calc, linear regression, L1, L2. We're all good. Calculate. And now let's look. So we got a 33.333 repeating. So I'm going to write my regression model. So line of best fit. So it was T and capital T. So I'm going to write capital T hat is approximately 33.333 T plus 1331.333. And I'm going to write down that R value. So notice the R value is a 0.709. Okay, so it is higher than 0.5. So it's a strong relationship, but it definitely is not as strong as what we saw in the last question. Okay, so now let's look at part C. Part C says write a piecewise defined model for the data. Use the graphing utility to graph the piecewise defined model. So now what they're asking for us in part C is to say, hey, you identified the two parts. So let's come up with a linear regression for this first half and a linear regression for that second half. So here's how we're going to do this. I'm going to go into my stat, and I only want to plot these first 4 points. So that means I'm going to go into my lists here. And what I want to do is I want to just erase everything from 4 after. Okay, so I'm going to just hit delete, 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 delete. Okay, so I go over here now to the left and I hit delete, 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 delete. So I'm only plotting those first 4 points. Now what I'm going to do is, to save time, I'm going to go ahead and now I'm going to rewrite for L3 and L4 the second group. So 4, 5, 6, 7, 8. And I'm going to copy over those numbers. L4 would be the other Y value, so 1308. Whoops, missing a 4 there. 1488. There we go. 1591 and 1682. There we go. All right, so now we're going to come up with that linear regression. So I'm going to go stat, calc, linear regression. So L1, L2 is going to be that first group here. Okay. And now watch what happens. Woo, look at that R value. So that first model. Okay, so this first group right here, I'm going to label these groups just so we're clear. So this is group 1 and this is going to be group 2. So for group 1, I got a regression model of T hat is approximately 83.2 T plus 1304.2. For group 2, now let's get that regression model. So I'm going to go stat, linear regression, and now here's where things are going to change. I don't want L1, L2. Now I want is what? L3, L4, the other half of that list. So how do I type in L3, L4? Look right above the 3 and the 4 on your calculator. You're going to see them blue. Hey, there's the L3, the L4. I see L5, L6. So all you just have to do is second, 3. There's L3. And for Y list, second, 4. And now I got L4. Okay. And now we're going to calculate. And now we got a new equation. And look at that R value again. Woo! Looking pretty. It's almost 1. So that's why it looked like 2 separate linear equations. And that's because this model would be better. So this is 94.2 T plus 928. So separately, we get way better R values than if we were to mash everything together. Look at the R value here. But if I separate them and kind of look at them in pieces, I get way better models to approximate the data. So that's why they're saying make a piecewise model. So now we got our 2 linear equations. So here would be my piecewise model. So t hat is approximately, and how do we get that approximation? My first equation, 83.2t plus, plus 1304.2 when t is between 0 and 3. So when we're between 0 and 3, we're going to use this model. Okay. Now when we are, whoops, did not mean to write it like that. Now when we are greater than 3, but less than 8, then we're going to use the other model. So I'm going to copy over that equation. So 94.2 t plus 928. So this would be my line or piecewise function to define my lines of best fit, because it would be a better situation to split it up as I saw it visually. Okay, so part D now says describe a scenario that could be the cause for the break in the data. So what could you think have happened to cause this to occur? So notice the number of stores went up, and then all of a sudden we get to 2004 and we had a pretty big drop in the number of stores, but then it started to increase again. So what could be the cause for something like that to occur? So one thing could be, as I had alluded to earlier, maybe there was a recession. All right, stores had to close. Look at what happens now with the pandemic. Stores couldn't be open, right? Because everybody's staying at home. And if they couldn't adapt by maybe doing stuff online, hey, we got to close our doors. So now some stores are closing in places where the pandemic is hitting harder. And then what happens? Okay, things start to get better. So then the number of stores will again begin to increase. And that's the hope that people have now. It's like, okay, well, once this is over, once maybe a vaccine comes out, maybe, you know, there's herd immunity, whatever. Now what's going to happen is, okay, things are going to get back to normal, but it might take some time for that to happen. So now that's where I start to maybe see that increase. So that's one explanation of what could be the cause behind this data. Now, are we ever going to know that? Well, we can look back in the history books, but in terms of looking ahead into the future, I can't predict the future. Nobody can. Even with all this math, all we can do is extrapolate and say, hey, if everything remains the same, I think this is what's going to happen. But don't quote me on it, because I can't guarantee you that everything's going to stay the same. All right, so that does it for our pre-cal question. So I want to keep this video short. So what I'm going to do is I'm going to record another video with the other half of the questions, which are really just from the past assessments. So if you found this video useful, you found a little bit entertaining, make sure hit that like button at the bottom. That's how I know these are being effective. Hit the subscribe to the channel as well, and I will see you guys on the next video.